So, scatter plots. So we're talking, this unit, we're starting looking at bivariate data, all right? And so we're looking at the relationship between two variables. Now, at this stage, by the way, it suggests that you're supposed to already know how to do things like cumulative frequency and working out means and modes and all that kind of stuff. Is that correct?
I think we need a little refresher. I think I remember the words being spoken to me.
Okay. Alright, so maybe we're not to go back, because if I take the units that we're supposed to do for extended and even standard maths, that's a kind of, you're supposed to have done that previously. So we can have a bit of a recap, but this would be a great unit for you to do another kind of investigational assessment rather than just a test. So let's have a look at this scatter plot. What does it mean to you, just looking at it? Great.
Shows me that there's no correlation between...
Oh, so you have to.
Huh?
Go on then.
Yeah, it shows me there's no correlation between students' grades in math and their grades in art.
So you have all done scatter plots before, or is that new to what you just said?
No, but it's just like from context, you can tell that...
But you use the word correlation. So you all heard the word correlation?
Yeah.
Correlation with
I think Greg just tried to use the biggest vocabulary.
It's
There's the correct.
Yeah. Situation.
What other ones?
So I've got here, it says state the form, direction and strength of any correlations. Okay? So let's discuss those words for a start. So form, strength, I did it in the wrong order, but direction. These are the things that we need to discuss. So form, all right, strength and direction. So form would be whether we have a linear or a non-linear relationship or correlation. Okay. Strength goes in a range, okay? But we can basically have none, weak, moderate, strong, or perfect.
We're talking about the strength of.
Strength of the correlation.
So like,
What's sense?
like x equals y would be perfect correlation between...
Exactly.
X.
So when we have an actual function, we have perfect correlation between x and y. All right.
Oh, these terms seem pretty unmathematical. Like they're very
They're a
subjective.
basic. Yeah, we do get to a stage where we start putting values to it with a mathematical process,
Yeah.
and that is called linear regression.
Yeah, what's the difference between none or weak and moderate?
Okay, that's a good point. That's
Minus,
good.
right.
Ethan asked a question though. He was like, well, about strength of what? And what does that mean? Okay, so the word correlation is another word for relationship, yeah? Stop moving my computer. So the word correlation is another word for relationship. So is there any relationship between the two variables? So what Greg said with this one is there is no relationship between the two. Or we say there is no correlation. Alright? So to be honest, as soon as we've got there is no relationship, everything else is kind of null and void. We don't then say we have a linear no relationship. That makes absolutely no sense. The one thing we haven't mentioned yet is direction, which could be positive or negative. Okay. So we're now, and this is a great topic for talking real world applications. So we are analysing a situation. we are trying to do a mathematical analysis of the relationship between two things. Why do you think we would want to look at a relationship between two things? Greg?
Well, there's many ways. So, like, maybe finding cures for disease.
Didn't ask how.
Oh.
It's like, why would I want to?
Yeah, to find.
Give me the beginning steps, though. What are you looking for? If you're talking about
correlation.
To find maybe doing one thing leads to another thing, or if.
Okay,
if
so you were
want-
talking finding a cure for a thing. So you're looking for if I change,
Yeah, something.
like what?
I don't know. Maybe the
If
amount
you eat
of.
mold, you probably have a higher chance of getting
Yeah.
sick.
Okay, yeah. Has anyone gone through a process of kind of a diet evaluation? Yeah, so you can kind of go, if you're feeling sick, I know a lot of people then go, right, let's try and sort this out. And what they do is they kind of cut a lot of certain food groups out and food types and see whether that makes you feel better. And if you do, then they start introducing new ones. So they're trying to find the relationship between what you're eating and whether you get sick or not. And that's kind of looking at relationship.
Yeah, like also an example from the one we have here. Your score in a test is correlates with the amount of revision. So maybe the person who was wondering, oh, maybe if I study more, I'll get a better grade.
Right, and then that's an important point. What are you saying that person is now doing?
They're like investigating it.
They're investigating and then doing what with their they're concluding and then making a
Statement.
or
Hypothesis. No.
my word begins with P. I'm not saying you're wrong with the hypothesis. Prediction is what I'm thinking. So you can make a prediction on what you think is going to happen based on a relationship that you've seen. All right. Now, what would affect how good your prediction is? Greg's talking over it. Anyone else got any ideas? Kieran? Pardon? How accurate your data is. And how would I know?
Like if doing this example and someone's like, oh, I studied for about an hour. That's pretty vague.
I know that. Actually, if I said to you, how long have you studied for a test? You are, yeah, like 3 days. I know 3 days means 25 minutes on a Monday, and then I looked at it for about 30 seconds the other 2 days. You know, so yeah, active collecting data. But another thing which I'm sure Greg's going to mention is
Sample size?
yeah, if we've got enough data, we obviously need more data. The more data we have, the better our prediction can be. But also,
Like, for this, like, exact one, it have to be, like, the smartness of the student to start with.
Yeah, you have to have
Because if
the
you-
exact same.
Controlled
Like, if you
variables,
took
the IQ.
If you took Tebow and told him not to study, so he was like, and then you
Okay,
took
which one?
me, and then you told me to study a bunch, maybe we'd end up with the same grade, which would be not fair though if we switched roles.
okay, yeah, that's part of it, how we're doing the process. Let me take you a step away from that thought process and ask you to think about, let's say someone else is doing the data collection. So you have no influence on it, you just get some data. All right, and let's say I have that result in front of me, that graph, the first one in front of me, and I say, right, I want to try and make a prediction on what. So let me give you a real world example. If you're absent for your art exam, but you were there for your maths exam, and I had to give you a grade for something, okay? Could I look at your maths score and try and predict what you probably would have got for art?
No.
Why?
Because as you can see with this graph, there's no correlation.
Exactly. So
Terrible.
I would find it almost impossible to predict your art score because you can see that, and this is where we talk about interpret the meaning of each chart in context. This person, how would you describe them?
Pretty good at math, but sucky at art.
Thanks for putting your hand up, Kieran. Pretty good at math, not so good at art. This person, Kieran?
Probably. No, they're not that good at math, but they're pretty good at art.
This person, Ethan?
Oh, they're trash both.
This person, Ethan?
It's like average in both subjects.
Okay, so we've got full range, because finally, Tatum, we've got someone that excels in both. So we've got a full range. There is no way of predicting. You might be great at maths, rubbish at art, great at maths, great at art. You know, it doesn't matter.
Average in both.
All right, could be average in both. So if I know you've got a really good math score, I have no idea what you would do in art. No idea. Okay, and that's because of the strength of the correlation. Okay, so the ability to predict. This is a big word. The ability to predict is based on the strength of correlation we've got. So we should write that down in our notes. So the strength here, we should say, is important for predicting. So it's very important for predictions. Greg?
So like, for example, if you had an x equals y graph that only went up to 5, since the strength is a perfect strength, you could easily predict that, you know, the next x variable is intersect with y equals 6, or, you know what I mean?
I do, and well, then we're also talking about, you come into another thing, which is about, and you'll love this because of the words, interpolation or extrapolation. We'll talk about that in a bit, but that's another limit. This is a topic that has lots of justification and validation and verification all mixed in, this data collection stuff. So we're saying strength of correlation is really important for any kind of prediction purposes. The only reason we do this data collection is to look at a relationship so we can make predictions. If we have a perfect correlation, that means we've probably got a very clear mathematical function. So the relationship between x and y, well, you already know there are so many different types of correlation, aren't there? There's a linear, y equals mx plus c. There's quadratic, there's cubic, there's quartic, there's sine and cosine, there's all the functions. They're different relationships that, you know, when we deal with real world stuff, we can have different ones. So we've got the next one. We'll go back and write some notes afterwards. What would you say different about this one? Yeah.
The strength is slightly better. Weak, moderate.
Maybe weak, maybe moderate. It's a good question. How do you know the difference? When we get a number, we'll talk about it next time. We'd reckon, is there a positive correlation, negative, or do you not know what that means?
I think it's positive.
Why would you say it?
It generally goes into the positive direction.
Okay, and how could we say in context of the situation here? So a positive correlation suggests...
When there's a positive increase in height, there's a positive increase in shoe size.
Okay, so does that make sense? Tatum, go on.
For the first one, will the direction be negative or positive?
As I said, if we say none, the rest of it is null and void. We can't have a direction if there is no correlation. So we've decided there is some form of correlation, however we want to describe it. Now we can say, is it positive or negative? We think it's positive. In context, does it make sense? As I'm taller, I have bigger shoes.
I mean, yeah.
Yeah, does that make sense? Okay. What about the next one? Yeah, pretty strong. They like putting those amount of revision and score in a test. You might argue.
Disagree with that.
What I find quite disheartening about this one is that you can here look, it looks like I can do some revision and still get nothing in the test.
Yeah.
That's harsh, isn't it? But that's what they're suggesting.
Harsh reality.
Yeah. Well, I would actually say you could do no revision and still score in the test.
I think you know if you pay attention to everything, I think
Yeah.
the most perfect.
I would say. You know,
Or if you see the answer before.
maybe. Yeah, especially if I give you all the questions. Yeah. But we've got a much stronger correlation now, haven't we? Now, what do you think? If you said to me, I revised for 5 hours, if I had units on my thing, would I be able to make a prediction?
Yeah.
Yeah? Think because
I mean,
Okay.
Well, it depends. No, you can't.
well, I can predict. I can always predict. What we're talking about is how good a prediction is likely to be. Yeah.
based on this information,
Yes.
I think you could make a strong prediction. However, in the real world, everyone they could have revised just by reading it,
Yeah.
like half reading it.
So we're making lots of assumptions still. That's why there's a lot to talk about here. Yeah, I mean, we're assuming that the next person I add to that graph, that chart, has done what everyone else did. It doesn't necessarily mean that is true, but if I'm going to predict, I would, let's say they did that much revision, I would kind of go up here somewhere in the line and predict that score. I might be wrong. But what about this one? Better prediction, worse prediction?
Worse.
Because
Because with the other one, it's a fairly straight line. They're all more tightly packed. This one's over very large.
yeah, so if I predict that height, if I want to guess your shoe size, where would I say? So basically I could be anywhere from here all the way up to there. Look at the space for my prediction. Whereas on this one, space for prediction's a lot smaller. So my chances of having an accurate prediction are better. Okay. What about this one?
Pardon? It has a negative direction.
So it's negative, and that is because the weight of the car and the gas mileage are related such that
as the weight of the car increases with gas mileage.
I'm going to ask you about choice of axes in a minute, and this is a really good one to discuss that. But yeah, reckon negative as the weight decreases, the gas mileage goes up. That makes sense?
Yeah.
Yeah, use less gas, better gas mileage. But can you see it's a negative, strong, moderate, weak? Moderate maybe? Weak.
I would put moderate.
What about this one? Is that the same one? Did I copy it twice?
Yeah, that's probably it.
Right, there's one missing. What about this one? Yes.
Was the last one linear?
Oh, really?
This one?
Height?
Yeah, I'll go with a linear.
Is the height like the height of the person?
I understand this graph, but I don't know how would somebody attain this information.
Yeah.
Okay.
I-
Well,
probably-
It depends.
Like your chance of being
The answer in the book has nothing to do with people's height. Okay? You can come up with your own concept. And we're talking about probability, so you're saying the chance of getting something that is a height like
rolling
that.
a dice, the chance of getting like a 3 or a 4 is probably
Yeah.
like
Yeah.
at the top.
No, it's 7. Well, yeah, if it's one.
Yeah, so if I changed it away
if
from
it's one
height,
dice, it's the same.
Oh, but if it's
If
two
it's
dice,
two dice,
if
it's
two dice,
7.
it adds up to
7 has the highest probability.
yeah.
Is it positive?
And then it goes down.
Okay, so let's, before we talk context, Ethan said, is it a positive or is it negative?
No.
None? See, I would actually say this is actually, is quite a strong correlation. But it's not a linear correlation.
Isn't it like
This is a good quadratic.
Well, I was going to talk about the whole thing. So, but that's where, if it's non-linear, the direction issue comes in. It is, direction isn't none. You don't have no direction, you have no correlation. If we have a correlation, we then look at direction. And this one, guys, linear has positive and negative. Okay? Other shapes that you might see, what about an exponential relationship? Yeah? They would go up or they could come down. All right?
This is an exponential.
This is not. I would say this would be more of a quadratic, couldn't it? It's a lot like
It
Parabol.
doesn't look like the x squared.
But isn't it like a parabola it's like reflected across the.
Doesn't
'cause
have to
you
be.
can't have negative height.
Move it, exactly. So their example in the book was the probability of a tower. So they were saying, I don't know what the tower was, but this is in the book. So the probability of having a really small tower is very low. The probability of a very high tower is very, and the towers are in the middle. So I don't know whether they were saying if I pick a tower at random in a city, or I don't know, you know, what's the probability of picking one that is? I don't like, but but it can happen. It could be a chart in that way.
It's like probability of a tree growing to a certain height.
I would probably go with that one's a better one, isn't it? So here you go, plant a tree. What is the probability that it will grow to? So that's probably a much better one than the one in the book, isn't it? I'm trying to predict based on probability. So would I predict a really tall tree, a really small tree? What will happen? You know, go with a medium height tree. But this is definitely, there is a relationship. It's a non-linear relationship, and that's all we'll write at the moment. Okay? So, that have you made, you can make your notes on any there. Could you just make a statement about the difference between positive and negative correlation for me? Write it down. Okay? So for each one of these, I want you to describe the strength, the relation, the direction, linear, non-linear, that kind of thing, if you haven't already. And then I want you to try and come up with, how would you explain to someone the difference between positive and negative correlation? So, could you give me an idea about a possible thing for positiveness? Definition of positive or negative correlation. Ethan, you were going to start.
I was going to say, well, positive correlation as one axis, like as increases, as does the.
So don't say axis, say variable, because the variable.
As one variable increases, as does the other.
Okay.
That's
quite like that. As one variable increases, the other one also increases. Is that what we agree with?
And yes. And with negative, it's the opposite. As one variable increases, the other decreases.
Okay. Greg, what are you going to say?
Could you say for a positive direction that both variables are directly proportional with each other?
Well,
and then for a negative direction, inversely proportional with each other?
Well, I wouldn't go with the inverse proportional, because remember what a graph looks like for inversely proportional. Reciprocal function type thing.
Oh yeah.
They're still directly proportional, actually.
Yeah.
Positive and negative are definitely both directly related. Okay. But I go with what you were saying. So if we say positive, we can go with, and you can do this in words, but basically, if one increases, so does the other. But this is the thing some people get wrong, which is as one thing decreases, so does the other. Okay? They basically do the same thing. A negative relationship, or a negative correlation, as Ethan said, is as one thing increases, it causes a decrease in the other, or if it decreases, it causes an increase. Okay? And we need to talk about different options. Now, there's some words that I want you to write down now. Maybe you want to do it on the back of your sheet. Okay? Which are, we'll talk about these next time. I would like to talk about causation or causality. Okay? And we also need to talk extrapolation and interpolation. And if you want to go away and look those up first, we might get a head start in what we're going to talk about. Okay?